Hello, everyone, and welcome to the second session of the security track this afternoon. It is my pleasure to introduce Dan Callahan from Mozilla, who will be talking to you about quick wins for better website security. A big hand.
Thank you. So what I want to do with this talk is give you a very broad overview of techniques, some which are really rather underutilized, that with minimal effort you can use to dramatically improve your site security. I'm going to be talking about security in 3 domains: when you're transmitting content, when you're rendering content, and when you're storing content uploaded by users or generated otherwise. The most important thing you can do to improve your website security when transmitting data is to use SSL. This has been a pretty rough year for SSL. In 2014, Apple had the double go-to-fail bug, which wouldn't be possible in Python because we have significant white space. But unfortunately, we have not yet taken over the world. This short-circuited certificate validation on iOS and OS X devices. And then just last week, a bug in OpenSSL referred to as Heartbleed was disclosed, which leaked private key material for several million sites on the internet, which is also not an ideal situation. If you're running any sort of site over SSL, please go update your cert and revoke the old one. But seriously, you need to use SSL because SSL is the only widely deployed technology, the only tool we have to protect data in transit from eavesdroppers. And when I say that, what I mean is when you normally go to a website, say yourbank.com, when you type that into your browser's address bar and hit return, the first thing your browser does is presume that you mean to attempt to connect to the insecure, the HTTP-only version of that site, the http://bank.com site. And it sends a request that says, hey, bank, give me your index page. And the server will usually respond, if it's a bank or some other secure institution like Hacker News or GitHub, with a redirect that says, actually, please go and talk to me on port 443 on my HTTPS, my SSL version of my site. So your browser will resubmit the same request over SSL, get a response back, and you'll actually have content and you're off to the races. Of course, with each request, your browser is going to send cookies, as browsers do for that domain. Fortunately, by using SSL, you're protected in case, sorry, I messed up that transition. Imagine an attacker in between you and your bank. If you're using SSL, you're protected in case that attacker is listening to your communication, because everything over the SSL secured link is encrypted. The attacker, without knowledge of your server's keys, which, Heartbleed, I know, has no idea what you're actually transmitting to that site or what the response is. But that first round trip, that connection to the HTTP, the insecure version of the site, is still visible to anyone that's listening, anyone that's on the same network or in between you and the site you're trying to reach. And with that request came session cookies. Normally, when you log into a website, the site will set a cookie that identifies you. It'll be some sort of long, maybe assigned string in a cookie. And if anyone can see that cookie and can copy it, they can impersonate you on that site, because that's what the site's going to use to identify you for subsequent requests. A little while ago, someone actually weaponized this in Firefox and created an extension called Firesheep that gave you a really beautiful sidebar with a big Start Capturing button. And when you click that button, it would listen on the local network and look for any insecure request that had a cookie header with a session cookie. And it would give you this wonderful, really easy to use menu of all of the accounts that you could just hijack by cloning that cookie. And so with one click, you could be logged into Facebook or Twitter or GitHub as someone else if you had seen a request that they sent over HTTP before they got redirected to the SSL version of the site. So using SSL alone isn't enough, because there is still that initial insecure request. And the way you can mitigate that is by using secure cookies. So normally the way a browser will accept a cookie from a website is in the responses, there will be a header called setCookie, which has a key equals value parameter. And if you append to the end of that header, semicolon space secure, you can instruct the browser to only transmit that site or that cookie back to the site if it's communicating over a secure link. So the attacker would still be able to see that initial request and response, but the session cookie wouldn't be transmitted along with that first request because it was marked as secure. However, if that attacker can see that initial request and response, they very well may be able to tamper with it. They can modify the request, they can modify the response. You can't really trust anything coming back that's not secured over a link with SSL. As a real-world example, imagine going to bankofamerica.com. If I type bankofamerica.com in my web browser, hit return, I go through a series of 3 requests, 2 redirects. First, I hit HTTP bankofamerica.com. That redirects me to www.bankofamerica.com, which then redirects me to HTTPS www.bankofamerica.com. So to load that bank's website, I had to go through 3 requests and 2 redirects before hitting a secure channel. And an attacker, if they were able to insert themselves into the middle of that communication, could potentially alter that redirect and send me to a malicious domain, say bank0famerica.com, which could be a legitimate domain with a legitimate SSL certificate, but it's probably not the domain I intend to visit. But what's worse is the attacker could decide, instead of just modifying the redirect, they could just serve you wholesale a completely fraudulent copy of the website and never forward your request on whatsoever. Again, if I'm not communicating over SSL, I can't really trust where the data is coming from or that it hasn't been tampered with. The Electronic Frontier Foundation just published a blog article urging websites to use SSL, and in discussing this, it provided a screenshot of Internet Explorer 11 loading the Chase Bank website, both over a legitimate secure connection and over a hijacked insecure connection. And one of the things, if you can modify the response, if you're an attacker in that situation, you can change the favorite icon, say, to the icon of a lock. And when you load that page, you end up with something that looks like this. And how many of you in this room are certain that you know which of those 2 screenshots is the secure version of the site? And how confident are you that your friends and your colleagues would be able to detect the same and avoid logging into a phishing site? So what can you do? How can you prevent an attacker, a man in the middle, from serving up an altered, a forged copy of your site if they can observe that first transaction, if they can modify that first transaction? And you can do that by using strict transport security. So when I go to Bank of America, I went through 3 requests, the third being the only one that was finally on a secure channel. If I go to GitHub, even if I type explicitly HTTP, not S, just http://github.com and hit return, my browser only makes 1 request, and it makes it to the secure version of that site. And it's able to do that because in every secure response that GitHub sends, on every response over SSL, it sends a header called strict transport security. And that header looks a little bit like this. It provides a max age, and it says, for the next in seconds, remember this domain and only attempt to connect to it over SSL. And what that allows you to do is it allows you to completely eliminate that first insecure round trip. You don't have to get the redirect because your browser knows that it should be talking over SSL. So you can completely remove that initial insecure channel. Of course, the very first time, your browser has to learn about that header somehow. So the very first connection still has to happen, but it only has to happen once for all subsequent connections, as long as your browser's cache hasn't been cleared, to be over a secure channel. Firefox and Chrome also ship built-in a list of preloaded sites that have opted into strict transport security, which helps bootstrap that system and get you to your bank's website or to Gmail or to GitHub without concern for a malicious link at that first step. So for transmitting data, you should make sure that you're using SSL to prevent eavesdroppers from monitoring your content. You should use secure cookies to ensure that someone on the same network can't impersonate your users. And you should use strict transport security to ensure that your users are actually communicating with your site and they're doing it over a secure channel. Very easy to set up. Again, secure cookies are usually just a single configuration line in most web frameworks. SSL It's usually, they're copious guides for setting it up on Apache or Nginx or IAS. Strict transport security, again, it's a single HTTP header to dramatically improve your site security. What about rendering? Even though we've been setting cookies, we've been setting them securely so that they're not visible to that eavesdropper, if someone's able to inject a script into our page, they could still access the document.cookie property and retrieve the text of that cookie. And then they could exfiltrate that session ID and send it to some malicious server and then impersonate your user that way. The way you can mitigate against this sort of an attack is by using HTTP-only cookies. Now, of course, you should be sanitizing your input. It shouldn't be possible for someone to get a script into your page, but software is hard. Things happen. In the same way that we added the secure token to our cookie, we can add a token called HTTP-only, which instructs the browser to not actually make that cookie available to scripts on the page. It's still in the request, so your web framework can still see this, can still read it. Django and Flask will do this by default for their session cookies, but it's protected from malicious scripts on the page. But again, you have a problem if there is a malicious script on your page. And what can you do about that? A relatively recent addition to all major browsers, including Internet Explorer, is support for a content security policy. This is the single most important slide in this talk because this is not a widely used technology yet, and it should be. What a content security policy will let you do is establish a whitelist of every single external resource and where it can actually come from on your site. This could be things like fonts, style sheets, script tags, images, videos, anything that you can embed and link out to somewhere else and say, go pull this from CloudFront or go pull this from Max CDN or Bootstrap CDN. In a content security policy, you can enumerate and say, by default, only allow things from self, which means the same domain, the same origin as the current page. Or allow images from the same origin, or to be embedded directly with a data protocol. Or, for instance, scripts in this directive would allow scripts to be loaded from the same origin or from api.example.com. This allows you to create a strict whitelist to completely inoculate yourself against injected scripts. There's a special directive, I think it's unsafe inline or something for inline scripts. If that's not there, if your browser sees this content security policy and then runs into a script tag in the middle of your page, say just alert hello world, it'll look at that, it'll check the security policy, it'll see that that's not a valid place for a script to be coming from, that's not something you expected, and it will ignore it. Completely block that from loading or from executing. This is incredibly powerful. Of course, whitelists can be hard to add to existing sites, so there's a sister tag called Content Security Policy Report Only that you can send with the same parameters. And what that will do is allow you to continue with everything working, and whenever the browser would normally block something with that policy, it'll allow it to load, allow it to run, but it will also log a message to your developer console telling you that, hey, this policy wouldn't have allowed this thing to run. Are you sure you don't want to adjust your policy to let that in, or maybe move your script to a CDN somewhere that you do allow? That's how you can audit your current site for the support of a given policy. If you're doing these 5 things, you're doing extremely well, especially if you have a content security policy. Again, this is relatively new, has broad support in browsers. Internet Explorer still requires a prefix and has a slightly restricted set of directives that it supports. But broad support, this is your best second line of defense after making sure you have good input sanitization, making sure that things are coming from where you expect them to. Nothing else can do what a CSP can do. Once you're there are 3 other headers you can set that provide additive security in different esoteric cases. You can set frame options and instruct the browser to completely deny framing of your page. Say, I can't, I'm not allowed to load this in an iframe. I'm sorry, site, I'm just not going to load it here. This will prevent clickjacking attacks. You may have seen huge Twitter bombings, like I believe it was about a year ago, where a site had loaded a Twitter page with a pre-filled tweet text and a big tweet button in an iframe, set it invisible, and then put that on top of some sort of game or some sort of other button. So when you click, you think you're clicking on this button below, but your click is really hitting this invisible iframe and sending a tweet. Extreme options deny will prevent that from being possible. Django ships with a middleware that will do this for you by default. Flask, Pyramid do not. You can also set same origin as the directive to allow other documents on your own domain to embed that page. Or if you need to allow embedding on another domain, you can set allow from the given URI for a single domain. Unfortunately, that's not as widely supported across browsers, but if you do need to allow embedding of a site in a frame somewhere else, that's better than nothing for the browsers that do support it. You can also set XSS protection. So Internet Explorer and Chrome support a header called XSS protection, which you can set to one mode block. And what that will do is it'll use heuristics to look at the scripts that it's about to execute, and if it looks like that script may be vulnerable to some sort of reflected cross-site scripting attack, if it sees query parameters reflected inside the script itself, it'll simply prevent that script from executing. Again, this isn't supported across all browsers, but it's a very powerful tool as a third line of defense if your standardization and your content security policy somehow allow something to slip through. Lastly, you can disable MIME-TYPE sniffing. Some browsers will look at the first few bytes of a file and try to determine what it is, regardless of what content type it's sent as, which could lead to something that you intend to be plain text being misinterpreted as HTML, and content that you thus thought was static turning into active, live, scriptable content. You can disable that by sending the X content type options no sniff header. So again, 3 headers plus content security policies, and you've dramatically improved your site security. All of this, adding headers is like one line in middleware. Very, very easy to do it in a single afternoon. What about storing data? There are 2 principles when you're storing user-generated data. The first is to completely isolate anything that is coming from users. If you're allowing uploads of, say, images for avatars or other content, you need to put that content on a separate domain. Not on your main domain, not on a subdomain of your main domain, but a completely separate domain. You'll see this. Google recently moved all of the GitHub page, or sorry, Google moves all of its content to googleusercontent.com, and GitHub recently moved all of the GitHub pages content to github.io. And what that does is it allows you to avoid some esoteric session fixation attacks where content on that domain might be able to execute as if it was a peer to your own legitimate content and thus touch local storage or set cookies on behalf of the user. By isolating on its own domain, its own origin, you're not at risk for those sorts of attacks. The other principle is to avoid storing data that you don't have to store. If at all possible, don't use passwords. There are a number of federated login solutions, social things like GitHub and Twitter. If GitHub is appropriate for your audience, they also offer a login solution. I work at Mozilla, and I've worked on the Persona project, which is an email-based login solution that doesn't require site-specific passwords. The general principle is you can't lose access to data that you're not storing. Of course, it's important when you're looking at an authentication system to balance the needs of your users. So forcing everyone through Twitter or GitHub might not be ideal because they might not be willing to give your site access to those. So you should always have some sort of neutral email-based login system, either Persona or traditional email password system. But providing alternatives to a traditional password-based authentication system will lower your surface area risk, lower the severity of any sort of compromise you might experience. So in summary, when you're transmitting data, use SSL to ensure that eavesdroppers can't see what you're transmitting. Set secure cookies to ensure that your users' sessions can't be hijacked. Set strict transport security headers to ensure your users are actually talking to your site and doing it over SSL by default. When you're rendering things, make sure you've set HTTP-only cookies so that malicious scripts can't get access to your user session information. Use a content security policy to prevent malicious scripts or injected scripts or other content from loading on your page if you don't intend it to. Set frame options to avoid clickjacking. Turn on XSS protection and disable MIME sniffing to avoid other esoteric attacks. Isolate content generated or uploaded by users to its own domain. And if you can all avoid it, don't store sensitive data that you don't absolutely have to. Now, before I wrap up, I want to point everyone to 2 other resources that are absolutely phenomenal. The first is OWASP, the Open Web Application Security Project. That can be found at owasp.org. And it's a wiki-based encyclopedic reference. Top 10 lists of major vulnerabilities, explanations of what the problems are, how you can mitigate them, developer cheat sheets. It's a really fantastic resource. The second is Qualys' SSL Labs site at sslabs.com. You can point their tester to your domain, and it'll give you back a report card on how well your domain is supporting SSL, what cipher suites it's using, does it support perfect forward secrecy, is it vulnerable to Heartbleed, and information for how you can improve your deployment of SSL. It's a fantastic resource. So with that, I'd like to, I think we have about 5 minutes for questions. I'd like to direct anyone that has questions to the mic in the back corner. Thank you.
Hi. So if Chrome and Firefox ship by default with what sites use strict transport security to avoid that first potentially malicious connection, what exactly does the HTTPS Everywhere plugin do?
So HTTPS Everywhere, which is a Firefox and Chrome extension, there may be other browser support, that's published by the Electronic Frontier Foundation, is kind of like an opt-in to SSL for sites that aren't currently setting that header or haven't opted into the preloaded lists. So it's a browser extension you can use on your computer to say, hey, please avoid this first connection anyways. The STS header is a way for the site to do that for everyone.
Okay.
Hi. I was curious when you were talking about making cookies HTTP only so that scripts just can't access them. I was wondering if you have a JavaScript-heavy application that needs to do JS-based auth, is that going to interfere with that at all?
You should always be performing some part of your authentication on the backend server, and the cookies will be sent with that request per normal and should be retrieved by that request. If you need to retrieve the cookie, for instance, in Django, the CSRF token is sent in a cookie that is not HTTP only by default, so you can turn that on and off per cookie as needed.
Cool.
What's in the way of a recommendation for browsers to try HTTPS before an unencrypted connection?
Probably just history. There are a lot of misconfigured sites, particularly if you are CNAMing out to some other service and it might support SSL, but up until recently, SSL had a restriction of being one IP per site. And so things could just get messy and the web could break when it would otherwise work if there are multiple sites on a single host, for instance.
You mentioned logging to the console for report-only mode. Have you seen people doing plugins or other type of extensions to forward that report onto the server itself so that we can get aggregated logs about what's breaking or what's working?
I believe there actually is a directive that you can add that will do that. I didn't have a chance to look at that. I only ran across it when reviewing the slides. I would look at the OWASP page and it'll tell you more. Otherwise, I'm sure there are extensions out there that will gather that.
Thank you very much.
All right. Any other questions? Thank you so much.